Okay, well, I've got
Welcome, everybody. We'll be getting started in about 5 to 10 minutes. Good evening, everybody. Welcome to tonight's meeting hosted by the Paha Sapa Grotto. I wanted to get started on time here. We are going to give everybody like 2 or 3 more minutes just to get online, since it's people might be wrestling with technology. So hang in there. We'll be starting in just a couple moments. Is she listening to it? No, you listen to it? That's okay. That was everybody. You can't go to do that. It's going up rapidly still, so I'm going to get Which one do you have? I'm doing more on that one. 9. 98. Who's going to be there for 100? 100. All right. Are you wondering which one? Yeah. All right. I'm going to come back here. Am I unmuted, Adam? No, you're muted. Okay. You're good. No, you're muted. Unmuted? All right. Let's get this evening started. We're also wrestling with technology here. So welcome, everybody. My name is Chris Pelzarski. I'm the chairman of the Paha Sapa Grotto. And I know many of you out there are Paha Sapa Grotto members. And many of you are not, and maybe don't even know what the Paha Sapa Grotto is. I know that some of you found your way here because of the sinkhole situation out in Black Hawk. And probably heard that a bunch of crazy cavers went into the mine out there and mapped the mine. And many of you are probably wondering, who are these people and these crazy people, and why did they get to go in this mine? So I thought I'd just answer that question before we get Karl, our speaker tonight. Just let you know a little bit about the Paha Sapa Grotto. So we are a group of underground enthusiasts, mostly caves, as opposed to mines, caves being natural, mines being man-made. And our group, we conserve, explore, and we research caves. That's what we're dedicated to. We are a membership-based organization. If anyone's interested in supporting us, feel free to join our group. You can find us at pahasapagrotto.org. One thing I will say about membership in the group, if you're joining the group because you think that you're going to get to go in the Black Hawk mine or in any mine, that will not happen. And I'm just going to say that because we normally don't go in mines because they're a lot more dangerous than caves. And that mine in particular, people aren't going to go in there again unless it's absolutely necessary, and it's going to be the professionals that go in there. So that being said, if you have an interest in the underground, feel free to join. And oh, someone says I'm a buzzkill. I just saw that in the chat. Well, I'm sorry. There's other cool stuff you can do if you join the Paha Sapa Grotto, though. but I guess I just wanted to stress that we're like the professional underground people. And if you have any interest in caves, check us out. Right now, we'll be, for the time being, we'll be doing meetings online on the first Thursday of every month. And PahaSapaGrotto.org has our website information. But we have all types of members. We have members that don't go caving and just support because they think exploration is cool. So we also do work with conservation of caves. And really quick, I'd like to introduce one other person from our group. I'd like to introduce Ken Steinken with the Black Hills Cave and Nature Conservancy. And he's gonna talk about this group that we are partnered with and some projects going on right now. I'm gonna have to switch chairs with him.
Thanks for joining us tonight to learn more about sinkholes and why it's important to understand the connection between what's above the ground and what's underground. I think we've seen a real lesson about that during this last week. I'm Ken Steinken. I'm a member of the Paha Sapa Grotto, and I've been asked to share with you for a few moments about the Black Hills Cave and Nature Conservancy. This is actually an organization that was formed just last year by members of the Paha Sapa Grotto, the organization which is bringing you this sinkhole presentation tonight. The Black Hills Cave and Nature Conservancy is a group that strives to advance the conservation, restoration, and preservation of caves and natural resources in the Black Hills. And we plan to do that through land ownership, scientific research, and public education. Part of that mission includes identifying where caves are located with the idea of preventing people from developing on top of them. We're excited that we're on the verge of establishing our first conservation project, a 44.8 acre property with 7 caves on it near Rapid City. We are raising $250,000 to create this preserve and provide for its ongoing upkeep as well as protect additional Black Hills Cave properties in the future. If this is something that you're interested in and like to find out more about the Black Hills Cave and Nature Conservancy and maybe even see how you might be able to help create it, you can go to blackhillscaves.org and you'll find some information there. The Black Hills Cave and Nature Conservancy is a 501c3 nonprofit organization, so your donations would be tax deductible. You can make a donation by sending a check to BHCNC P.O. Box 234, Rapid City, South Dakota, 57709, or you can donate online at blackhillscaves.org. I want to thank you again for joining us tonight, and I encourage you to keep exploring and learning about nature above and below ground.
All right, so we're going to bring on Karl here in just one moment. And the other thing I wanted to say, last thing I'll say before we get Karl, is if you have a cave on your land or a sinkhole and you're interested in what's down there, you can get a hold of us and we'll come map your cave. And if you think it's a big cave, we can produce a nice, beautiful map for you. Or if you're worried about the sinkhole, we can tell you, we can come and let you know if there's anything to worry about. So let's get Karl Emanuel in the seat here. And without further ado, here he is, the man himself.
What an introduction. Okay, good evening, everybody. I'm Karl Emanuel. I work for the Forest Service here, and I do a lot of stuff for them, but one of the things I do is I'm a geohazard specialist. I'm not doing this presentation as a Forest Service member right now, but as a member of the Grotto, okay? I participated in the looking at the sinkholes in the Black Hawk area, and I had already written up kind of a summary of what I've been doing with searching for sinkholes, and we kind of worked in the Black Hawk situation, and I'll go into that in just a moment. So let me get my stuff started here. Okay. Can somebody give me a screen check and tell me if that's working correct? Okay, great. Thank you. Okay, I'm going to talk to you about sinkhole identification, mostly for the Northern Black Hills, because that's where I currently have information I've been working with. Been using LiDAR, which is a technique that used to produce really accurate surface maps that have, you know, that you can see things on a sub-meter scale. Been using aerial photography and a lot of tools within ArcMap to produce maps which allow me to see sinks. And sinks are not just sinkholes, sinks are shafts, sinks are ponds, they're anything that has closed contour. So there's a lot of different things that are out there, and I'm going to go into that, but I am going to talk about the mine situation. I've got quite a few slides up here related to that. The first thing is, you know, the Paha Sapa Grotto, basically, we're cave explorers, okay? The Black Hills contains hundreds of caves, probably over 400 known or suspected at this point, and that's probably way, way low. The region is host to two of the world's largest caves and many others of substantial size. There are a lot of dots on this map there, and that's a geologic map of the Black Hills uplift, by the way. All those dots are not just single caves. A lot of them are multiples, okay? And if you look at it pretty close, all the dots are around the edges. And that's because that's where the sediments that host caves are. They're in the areas on the periphery of the Black Hills uplift. It's a big uplift. It's several hundred miles long and about 60 to 80 miles wide, depending on what you define on as the edges. Let's see, there's four main karst-bearing formations, okay? And one of them was involved in the Black Hawk situation. The Madison, or what we call a Paha Sapa limestone, is the traditional cave-bearing formation here in the hills. That's where all the really big caves are. But not all caves in the other units are small either. There's the Minnelusa, which has quite a few. There's the Minnetonka limestone, and then there's the Spearfish Formation, which really doesn't have a lot of recognized caves in it, but it has more sinkholes in it than any other unit that I've looked at so far in the areas that I've looked at. So there's a suggestion that there's probably quite a few unmapped or unrecognized caves in the area. Okay, I'll go on from there. Let's see. This is a great picture. I hope that turns out good. This is a couple of sinkholes that are on the west side of the Black Hills uplift in an area I don't have LiDAR, but I could see these things in aerial photography, okay? They're pretty awesome, and but they're also within this, right on the edge of the Spearfish Formation, the same formation that we're having problems with in the Black Hawk area. Part of the reason I'm using the LiDAR technique is that it's very difficult to find sinkholes as you're wandering around in the woods. Some of these things are huge, but a lot of them are fairly small. And you might think, well, that's not all that hard to find. But I've spent hours in a very small area looking for a sinkhole and then parted bushes, and there it is sitting in front of me. It's a difficult thing to do when you're wandering around in the brush. So we're using modern techniques and trying to locate areas that have potential for additional caves. Okay. One of the big reasons that we study sinkholes is we want to identify these features because they are a direct link into the groundwater system, okay? Sinkholes can lead into underground caves as well, but they don't necessarily have to lead into a cave, but very, very many of them actually do lead into caves, or a significant portion thereof, let's put it that way. Sinkholes, mine collapses, which are sometimes referred to as sinkholes, are very, very karst-like. They look just like a sinkhole, but they're caused by, subsidence, but they're not truly a sinkhole. I prefer to call them a mine collapse. That way we understand that there's a little bit of a difference between the two. One is caused by the processes of dissolution. The other one is caused by human extraction and removal of material. Mine collapses are hazardous. Caves not necessarily so. Okay, if we got it, okay? Okay. Okay, we are having slight technical difficulties at this point, but we are about to get it fixed, okay? We've got enough cooks here to spoil the broth. Let's put it that way.
Do you want to duplicate them because it was extended and that's why you don't want to
Can we
duplicate
turn those on? You can't.
them?
Should be the sidebar. If we, yeah, because it's, yeah, right there. Hi, video panel.
Yeah.
Thank you. Okay, it was covering up half of what I was trying to use as prompts. Okay, great. We're back on track, folks. Okay, these, okay, so mine collapses, like I said, are extremely hazardous, okay? Caves and mines are two totally different things, although they both are, they're both connected to they both are forms of underground void space. Caves are formed by stable processes. They're over a very long period of time. They're in solid rock typically. They're usually not prone to sudden collapse. And they were formed by water flow in a very natural environment over a long period of time, and they're relatively stable. Mines, on the other hand, are formed by blasting, okay? And blasting shatters the surrounding ground. They're usually in unstable, they're in types of rock which are inherently unstable. They usually have to be supported by timbers or other support media, which weaken over time, and particularly timber, and some older mines rot, and we saw plenty of rotten timber. And they're usually ventilated mechanically as opposed to naturally, which means that you can encounter really bad air. You'll notice it says stay out and stay alive down there. That's my motto, okay? I've worked in the mining industry a long time. I've been involved in minerals a long time. And I've spent a lot of time underground in mines, and I did not enjoy going into that mine, but it was something we had to do because it needed to be done. Okay, we generally will only go into a mine or if it's in a cave-bearing formation, okay? In other words, if there's the possibility that it could have been a cave. And that's one reason why we ended up going to Black Hawk. It was in the Spearfish Formation where there are known caves within the cliffs. So we had to verify whether it was a natural void or a man-made void. Natural voids need to be conserved, studied, and protected. Man-made voids, we need to understand those as well, but more to ensure people's safety rather than just curiosity, okay? They are life-threatening, and I've worked in mines and I've been right behind somebody and just watched the ceiling come down on top of them. I don't wish that on anybody, okay? So I'm here to tell you, you wanna stay out of these things. Members of the Grotto we're pretty much the most experienced people in the area currently that do underground mapping and underground rescue. And we were brought in by the local authorities and emergency management to help out with this situation. It isn't something that we just really wanted to jump in and do. I had a lot of reservations about it personally. You know, you only can go on so many mines in your lifetime before you get really hurt badly in one. But we use safety gear, PPE. We had air quality monitoring equipment with us. With each of the groups that were in the mine, we had people stationed on the surface, emergency personnel. We had backup crews who could come in and rescue us with additional equipment. That's an awful lot of preparation to do before you go into an old mine. So it's not something you want to do casually, okay? Just remember that. Anyway, stay out and stay alive. That's all I can say is it's just important to let the professionals go in. We'll take pictures, we'll show them to you. If you want to go underground, we'll take you to a cave. How's that sound? Okay, I think I've said all of this, so I'm moving on. I got a lot of slides to go through. And oh, here we are. We got some pictures there. Mine collapse, they usually referred to as sinkholes. They're not really technically a sinkhole. They're a mine collapse. But, you know, most people think that they're exactly the same because they look exactly the same. All natural sinkholes form from bedrock being dissolved at or below the surface, whereas mines, again, are from activities, extraction activities underground and on the surface as well. But in the case of a mine collapse, it's typically involved with an underground. We've got pictures on the side here. I think I've said this. That's just actually, I'm going to rotate through. That's just one pic. That's an additional picture. A particular deposit was in, this is in gypsum, okay, which is very unusual to see an underground gypsum mine, but this was a very high-grade gypsum deposit once upon a time. The particular deposit's from about 3 to 10 meters thick, or 10 to 30 feet. It was dipping at about 10 to 15 degrees off to the east. There was abundant evidence that could be seen, and you can see it in this particular picture. You see all those little lines along the walls. Those are where there was drilling done to open up this particular room. And the down dip galleries in the mine were largely flooded all the way to the roof, which in mining parlance is called the back. And the walls are called ribs. And I tend to refer to them that way because I've worked in mines. Pardon? Oh, I need to speak up? Oh, no problem. I can speak up. Yeah, that's a dangerous thing to ask, okay? And I've got friends out there listening to this who are probably laughing when they hear that. More than one of them. I saw you out there, Brett. I know you're laughing, okay? Anyway, there's less, they mined out a fairly thick horizon in here, but they left a little bit of gypsum in the ceiling, usually less than about 3 feet. Above that was some really weak rock. And in a lot of places it had caved up into that. What you're looking at here is basically a very large room. And this mine was primarily composed of very large rooms. There was, again, there was water down in the lower end. This is a picture of Adam down in probably the lower end where you start to see the flooding. And it was, it's obvious that there's considerable amount of space going off in that direction, but it's below the water table. My current theory for why this thing is collapsing now is that we probably have had a drop in water table in the area. There's probably been an extraction someplace down dip, and down dip I mean lower in the system, you know, down towards the east where it's been drawing water out of the area. And when you draw that water out, things dry out, the roof starts to desiccate, and you get collapse. It's a fairly typical process in mines. But you'll notice that pretty much every picture we have in here shows big rooms. And that's because this thing was dominantly mined by what's called the room and pillar method. And that leaves small pillars all over the place within the mine, but extracts most of the remaining material. So there's very, very little support, and there's very wide open areas. This is a very dangerous kind of mine for people to enter because of the big, wide spans. Fortunately, this material is fairly competent, but it won't stay competent long. And in some areas, there were some terrible looking conditions in the ceiling. You really wanted, you needed to stay out of there, and we had to go around those particular areas. Anyway, this place has been dubbed the Hideaway Mine, and I'm not exactly sure. I think someone from Emergency Management.
It's called the Hideaway Hills Subdivision.
The Hideaway Hills Subdivision? Okay, great. And so named after the Hideaway Hills Subdivision. And anyway, the situation where you have weak cap rocks and large tabular rooms is a recipe for collapse. And being very close to the surface makes it even worse. And all these situations came together. This is another area. This is Ken Steinken and myself. Am I speaking loud enough, guys, at this point? Okay, thank you. Anyway, this is the two of us in a room that's probably, with the exception of that pillar, it's 50, 60 feet across, and you can see how the ceiling is bowing down, okay? That's the way it was mined, but that's a very unstable situation. you know, an upside down arch is not strong. And so you, I can tell you, I'm here to tell you, I've tried to build too many upside down arches. They never worked, okay? Oh, Lord. I'm digging myself a hole here. A mine. Anyway, this is a picture of the mine. And if you look at that, you can see that there's not a lot of pillars and an awful lot of open space, okay? This is a dangerous situation. You can also see that against the east side, or here, the right side of the map, you see blue, and that's where the workings are flooded. So there's workings off in that direction. But fortunately, they're deeper down, so there's a little less chance of those collapsing in the near future. But if more water is drawn out of the area, that may actually start to happen. The total amount of survey was about 0.44 miles of survey line in here, and it would have been considerably more if there hadn't been as much flooding in portions of the mine. The void space is definitely man-made. There was a little bit of evidence of dissolution along fractures, but very, very minor by comparison. I mean, it's less than 1% of the material I looked at, and I know pretty well what dissolution looks like in these rock types. I've been studying it for years, and so it's a man-made structure, and it's dates from the mid to early 20th century, and it needs to be avoided. So stay out of there. If you're close to there, don't be tempted to go down and look at it. Please, please, please don't do that. We don't want to have to come in and rescue you, and that's basically it'll be up to us in emergency management to do it. We don't want to have to go down that road, believe me. Okay, so I'm going to talk a little bit about the natural kind of sinkholes and what I've been doing with LIDAR. Okay, so this is sinkholes are solution-caused depressions, and they're in the ground surface, and they're largely or completely below the level of surrounding topography. So they're kind of like a bowl-shaped thing, which can be found using remote techniques, because you can model a surface and you can find where there's stuff which falls below level on the surrounding ground. Sinkholes are prominent components in most karst areas all around the world. We don't seem to have as many of them here, but I think a lot of that is just due to the fact that they're difficult to find in this kind of terrain. Occasionally, you'll see on some of these diagrams the term doline. Doline and sinkhole are pretty much the same thing. It's more of a European parlance. I use the term doline for dissolutional sinkholes, which is a type of sinkhole. And I use sinkholes for the term sinkhole for collapses. And that limestone pavement, if you can see on the top of that diagram, was exactly what was shown in that first picture with the big sinkholes. Limestone pavement with two huge sinkholes next to it. This is almost a cross-section through that first picture. Okay, a dissolutional or solutional sinkhole or solutional doline, they're caused basically where there's dissolution happening along fractures and joint intersections. Solutes move down into the ground, they start dissolving rock, and then they kind of plug themselves off, but you end up with a fairly smooth depression, rounded depression, which does not have any jagged edges, okay? And it's funnel shaped. They tend at times to fill full of water, creating marshes and ponds. I'm using the classification of Jennings 1985 for these things, not because it's maybe the best on the planet, but it's the one I'm most familiar with. And and there's some problems with it. There's problems with any classification network. But I just want to go into the different kinds. A lot of the ones here in the hills are solutional, okay? In other words, they don't necessarily lead directly into a cave, but they lead into ground that is cave bearing. So, and they're indications that there are caves in the area. So if you find a lot of these things, you probably are in an area that has cave developments within it. Then there's the cover collapse sinkhole, which is pretty much what we saw in the Black Hawk area, okay? It's where the material above is caved into an open space below. It's pretty much impossible, based on just morphology, to tell whether a sink, a sink of this type is man-made or due to man's activity or due to natural processes, unless you look into it or know which rock type it is. And if it's in the wrong kind of rock type, you can pretty much know one way or the other whether it's man-made or not. Over time, the edges start to smooth, and they get to look a little bit more like a solutional type sinkhole, but they tend to be steeper and narrower and fairly small. And we've got a lot of these types here in the hills. They're relatively small, they're relatively deep. And I've found a whole bunch in the stuff that I've been doing with LiDAR. Then there's this is kind of the same sort of thing. It's kind of a subset. It's called the subjacent karst collapse sinkholes. And if you can say all of that fast 5 times in a row, I'll buy you a beer, okay? At any rate, these things are more like where you do not have, this is the type of sinkhole that you're gonna see. Like we see it here in the hills quite often where a cave is just below a non-soluble rock type, like the Jewel Cave area is where it comes up underneath the Menalusa Formation, and the Menalusa Formation is not really, it's not easily dissolved. It's more of a sandstone situation. So these are fairly common as well here in the hills. And then there's, oh, I love this word. There's the substance or Suffosion sinkholes. And you actually cannot find how that's pronounced, but it's used worldwide except here in the US. It basically means that you have had, basically means that something has been undermined, okay? And it's, you have erosion on the surface, and suffosion is from below, okay? And so basically what this is, and we see this all the time here in the hills, when you find a sinkhole out in a gravel or a sandy area, you have, what it means is that deep underneath, there's something collapsing and the soil is washing into it and filling it in. And that's probably something very similar to what they have down in the Hot Springs area. To some extent, you had, you know, a lot of sediment dropping down into these things at one point or another. And I've seen a lot of preserved sinkholes that are filled full of sediment. And that's what this type is. We have them here. They're not highly common, but you do see them in sinkhole areas where sinkholes extend out into the areas that are covered by unconsolidated sediments like sand and gravel. And then we have the alluvial stream sinkholes, okay? And what this is where a sink forms in the bottom of a creek and swallows up the water. Usually leads into underground space. They tend to be flooded partially or all of the time. And we've got quite a few of these actually here in the hill. I know that both Box Elder and Bear Butte Creeks have some pretty significant sinkholes of this type within them, but that's the short list. The ones I'm most familiar with, there's many in the southern and western hills as well. Okay, so now that's just kind of a brief discussion of the types of sinkholes. Mostly what you're looking for is something that's relatively round and something that's relatively deep. We're using high resolution LiDAR imagery. Basically, it has about 1 meter horizontal and 5 to 7 centimeters vertical in our accuracy. And it's light detection and ranging is what LiDAR is, if you don't know. And it just became available for the northern part of the South Dakota Black Hills last year. I've only been looking at this stuff since last spring. And in the interim, I've found over 2,000 sinkholes based on this information. Now, what you'll see in here that I have a slightly lower number. It's because since I made that slide, I have found another 250. So, I mean, I haven't looked at all the LiDAR yet that we have. And I haven't even looked at some of the areas of peripheral to the hills where I expect to see quite a few because it's not within the forest. Mostly I do this for the Forest Service, so I concentrate on the forest lands. But I also look at some other areas that are BLM, government-owned lands as well, and I've found a lot of sinkholes out there. So anyway, with this data, I use using ArcMap to do all of using the USGS and Soil Conservation Service data that's out there. I'm producing a bare earth hillshade model. I'm producing what's called a hydrologic fill model. And if you're interested in how to do this, I'll send you the instructions. I've got actually 3 slides at the end which go through the boring process of doing this, which I'm not going to show tonight. If you want to know, let me know, and I'll let you know how to do it. And I also do contouring at 3 foot or less. So I've been doing 1 to 3 foot contours in areas that have a lot of sinks in them, and you can find incredible amount of detail. And this allows you to do it. So it's a really, really powerful process. And I also use a lot of Google Earth imagery to check areas out, which has been out there for quite a while, and high resolution area. But sinkholes are just one. Okay, yeah, we'll do questions at the end because it's because the technology to jump back and forth is probably going to sink us or okay.
Just to interrupt, there's a lot of people asking that live right in the neighborhood that want to know specifics about that neighborhood. Are you going to cover any of that?
Yeah, we'll do questions at the end, and I can answer whatever we know. But you know,
Okay.
we don't know everything about it at this point.
Right.
We only know we do have some suggestions based on old areals that there's other stuff on. But
So people can stick around to the end.
yeah, stick around to the end. I'll try not to bore you too much on the way there.
We'll answer questions as best as we can, but we don't know everything like Karl said. So
Yeah.
just hang in there.
Yes, hang in there. I'll try to give you at least a few neat things to look at anyway on the way there. At any rate, sinkholes are just one of a whole series of sinks. So what I did initially, this is the area that I initially looked at with LiDAR. I've extended it a little because the data up to the north to go out to the area around the fish hatchery, because that area has a huge number of sinkholes in it. One of the biggest collections of sinkholes in the hills are up by the fish hatchery along the state line. And there's also tons of them in and around and north of spearfish. So there's a lot of sinkholes in the area, and I'll talk a little bit about that as I get a little further on here. LiDAR is going to be available for Southern Hills. Actually, it's been flown. It just hasn't been manipulated and accepted by the Soil Conservation Service yet, because it has to make certain, it has to come in at what they call a QL2 or higher specification, and they haven't determined whether or not it makes specification yet, so they won't release it until then. Yeah, now if that's not geeking out, I don't know what is. Okay. Anyway, sinks include karst sinkholes, borrow pits, and a borrow pit's like next to a road where they dig out a little dirt, stock ponds, prospect pits, open shafts, mine collapses. Hey, mine collapses showed up again, and scour holes and stream channels. So you can see all of this stuff using LiDAR. Okay. So if you're living in an area that's prone to these, we can get and take a look at the LiDAR in your area and tell you whether you've got sinkholes in and around your place. But there's just one caveat there, is that if the area has been developed in the last few years, the process of development for homes has been to flatten an area out. And what that does is that fills in the sinkholes. And so you'll see that I'll find hundreds of sinkholes, and then you get close to like spearfish or get close to whitewood, not so much whitewood, but sturgis, you get close to blackhawk, they disappear. And then you get to an area that hasn't been developed and they appear again. And so it's there's been a lot of smearing of the data, but if there still should be evidence, if you've got subsidence going on right now in an area, it will show up. And it'll show up even if you've got an inch or two of subsidence. This is accurate enough to pick up that kind of displacement, particularly if there's no ground cover. If you don't have a lot of trees in there, you can see down to just 2 or 3 centimeter, which is an inch accuracy. Anyway, each of the sink types looks different when you look at them in LiDAR. And so what I did was I looked at a bunch of test areas, okay? And I used bare hillshade, hydrologic fill modeling, and sub-meter contouring. Okay, so I did a couple of test areas, and I did the test areas because I knew there was a cave, I knew there was a sinkhole, or I knew there was a mine, okay, or a collapse, so that I could see what they looked like. And so This is, and some of you will recognize this, but and I know everybody's going to hate me, but I didn't put names in here. Okay, I'm not going to tell you exactly what the names of these caves are. If you want to see some of these, come on, we'll take you there. Okay, come support us. We will take you there. We're not in the business of like giving people cave locations. Okay, we're trying to protect these things, and we want to make sure that people go to see them are people who are going to respect and protect them. And that's a big part of what our organization and what the Forest Service's policy for this stuff is as well. Okay, so this is an area that has a big sinkhole, okay? And then you'll notice there's kind of, you look down, you can see like a dimple in the ground. And you can see another little dimple really close to it. This is a hillshade model, okay? Now, if you, then I do what's a fill model, which shows where there's depressions and how deep they are. If it's blue, it's only a foot or two. If it goes to higher and higher colors, going towards the red end of the spectrum, it's deeper and deeper. In this particular one, orange would be about 8 meters, and that's 25 feet, more or less. And the blue is down around 1 or 2 feet. And the entrance to the cave shows with a bright blue spot in there. But what we didn't know and found out just from the LiDAR was that there was a large depression right adjacent to the cave, which suggests that there's something out in that particular area. So looking at this, when you go back, you notice that it's just a very smooth edged hole. There's no suggestion that there's a lip around the edge. And because if there's a lip around the edge, it's probably man-made. And I'll show you that in just a moment. This is another, oh, I got it there. That's Erskine Cave. I forgot to take that one out. Oh, well. I thought I got all of them out. Okay, that's Erskine Cave. Okay, somebody shoot me, okay? There's a gate on it, so yeah, you can know where you can know the name of that one. Okay, now this is what I found was that there were several sinkholes in the area, and the sinkholes have the kind of the circle around them with the shores. There was a whole series of like pits along the side of the road, which I call borrow pits or sometimes sumps. And then there was a few prospect pits in the area, which had lips on them. Prospect pits tend to be very small relative to sinks, and they have raised edges. And when they have the raised edges, says that somebody has dug into the ground and tossed stuff up around the edges. So you can tell the difference between a sink and a mine-related dig, not necessarily a collapse, though. Collapses look a little bit different. This is another area with another very large sinkhole in it. You can see it's down in this area. Can you see my my cursor there, guys? Pardon? Okay, so where the cursor is down in there, there is definitely there's a big sink in. This has a very complex underground network in it. Now, when I modeled it, you notice that one has some really deep colors. This thing is about 30 to 40 feet deep, where you can see in from above. It's actually deeper than that around the edges. But you can see a lot of information in here. And you can also see, if you go back, it's got a really ragged edge. This is a classic collapse sinkhole. Okay? At any rate, we will move on. And then I put in coding to show where the other features are. There were some other holes up in the upper left-hand side. Those all have lips on them. If you can look at that, you can see that they have a rim. That rim means that it's a prospect pit or possibly a shaft if it's big enough. But all of those turned out to be prospect pits. So before even going out to an area, I can usually tell whether or not I've got a sink or a mine-related disturbance. Okay. Also, just because I needed to look at what mines look like, I put in a few examples. Now, this first one, you look at this, you go, oh my goodness, that's a big hole. But there's something a little bit different about that. And if you look at this, you'll also notice that there's kind of a lump right here. And what that is that's a mine dump. This is about a 50-foot deep shaft. Very, very dangerous. And it's extremely deep. Okay. Now, usually it says right there, it says, oh, it's only about 9 meters deep. And 9 meters deep would only be 27 meters deep, something like that. The problem is with LiDAR, when it looks down a deep hole, it doesn't see the bottom, it sees the sides. And I found that most of the time when my data says that it's 2 to 3 meters deep, it's 6 to 8 meters deep. When I see something that says 10 meters, it's 20 meters. It's about half the distance that it gets down, because you generally don't fly directly over when they're collecting data. Now, this is an area that has prospect pits in it, very obvious. They have kind of a big rim along one edge. And there's also up in the upper left-hand side, there's also a very large quarry in the other area, in that area. These are obvious mine things. But this is an area with shafts in it. This is what a shaft looks like. You'll notice it has raised edges around it, okay? So if you've got a shaft in your area, we can't tell from aerial photography whether or not it's a shaft or a collapse. And again, these are as much as 6 to 8 meters deep on a lot of these. And this is an area that with a huge dump and 2 very large holes in the top. Those holes are actually mine collapses, okay? But they're in the top of a mine dump. This probably is about 1,000 foot deep. But it's not open all the way. It's open a mere 30 to 40 feet. So you do not want to go into that, I can tell you. And anyway, I had to see what mining stuff looked like relative. And this one, if it wasn't in the middle of a dump, I would have interpreted that as a sinkhole. It looks more like a sinkhole than it does, but I can see a big, huge mound around it. So that's a raised, just a very large raised lip. And that means that it is man-made. So we'll go from there. Now, this is the results of the initial sinkhole inventory. This is where I found sinkholes in the Northern Hills. Every one of those blue dots is a sinkhole, and there's 1,873 showing on this map. You'll notice very, very high concentration up in the extreme northern end of the hills. That's out in the area close to the fish hatchery, okay? There is hundreds and hundreds of them. And you'll also notice that there is a monster of a cluster that's over against the state line. Now, you'll notice that the sinkholes stop right at the state line. That's because that's where the LiDAR stops, okay? Once we do have LiDAR on the other side of the line, I anticipate that we'll probably be finding quite a few over there. And you'll also notice that they both abruptly or mostly stop about 3/4 of the way down the diagram. That's where the LiDAR currently stops as well. So I anticipate that we're probably going to be seeing this all the way around the entire hills, and we will be seeing probably 30,000 or more sinkholes found in the Black Hills area. That's a lot of potential caves, guys. A lot of potential caves. This is the Madison Formation. There was 687 found in the Madison, or what we call Paha Sapa, which is the big cave former here in the hills. Then there was quite a few, 300 and some odd in the Minnelusa Formation. And then there was just a few found in the Minnetonka limestone, which doesn't seem to have as many. It's a fairly thin limestone. But then I had 820 sinkholes found in the Spearfish Formation. And the Spearfish Formation is where the problem was that happened in the area around Blackhawk. So you not only have mining related subsidence in the Spearfish Formation, you've got a big potential for karst, which means there can be natural caves in the area. That's why the Grotto went to look at that site to verify whether or not it was actually a karst feature or a man-made feature. Okay. I really, so far, have only looked at about 35% of the LiDAR. And so there's potential for finding a lot more, but I've looked at the areas that I think have the highest potential at this point. So I'm thinking at this point that, you know, we've got a good start on it, but we've got a lot of work to do in the rest of the hills. Okay, I'm going to show you a couple of areas that have caves in them. This is one I call the North Slope area. Okay, all right. Keep going. All righty. Keep going. Okay. Full steam ahead.
Your numbers are going up.
The numbers are going up.
We
lost somebody. Oh, okay, we gained one. Great. Thank you. Okay, this is an area. This is the area I was talking about. I wandered around in the woods for an hour looking for one of these holes. I couldn't find it until I basically stumbled through some bushes and almost fell into I only found one of these holes, but there's a cluster in this area of 4 or 5. And you can see all kinds of dimples showing in this area. There's at least one known cave in this particular cluster. But nearby, there's a group of 7 known caves, some of which were found in the past by a number of our members, but at least 1 or 2 of them I found that I'm aware of at this point are new finds based on this information. So this is basically what they, I do the fill again. I didn't show any of the contouring because it gets too busy. I use that just to verify. But here is one with a couple of very large collapse sinkholes. And you can see right in here, that's what a collapsed sinkhole looks like. It's really rough edged, okay? This one in here has a square edge against one side. This one over in here has an angular edge. These are collapsed sinkholes, and they do not have rims. And there's other sinkholes in the area, which I had no idea were out there until I got the LiDAR. I found a couple of these pre-LiDAR, but it's just amazing what we have found since we've got this information. And this is the entire area, which is zoomed out. You can see, there's some pockmarks out there. But this is the total number of sinkholes. We found about 58 sinkholes, and all of those things that look like a Y with a squiggle on it are where we found it. Okay. Some of these were known about in the past, but a lot of them were not. So it's really a great tool for locating and finding karst, finding new caves, and making sure that they're protected and kept from harm. There's an awful lot of activities that go on in the Black Hills National Forest, timbering, all kinds of recreational activities. And we just want to make sure that those things can happen without impacting this particular resource. Okay, this is another area. This is my big find. I knew there was going to be a lot up by the fish hatchery, but I had no idea there was going to be a bunch off on the west side. This is this is a cluster of 650 sinkholes. Okay, that's a lot of sinkholes. I thought I'd find 20 out here, and I found 650, and some of them are huge. Most of these appear to be solutional. They're very round, but there's quite a few collapses as well, but the bulk of them are solutional. But there has to be caves in the area with this amount of karst development. So I'm going through this kind of quick, but if you look at this, you can see pockmarks here, 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 and here. But there's 150 sinkholes in this general area and 60 on this particular view, okay? And now if you fill in, you can see all these red dots here, here, here. And it's, I'm zoomed way far out so that it's just to give you an idea of how much they're clustered. And here is where they're showing. The interesting thing here is that there's trends. You see strings of these things which trend off towards the west-northwest. And that's all through that entire west zone. You see that same trend. You see strings of these things going towards the west-northwest, following structures. And that does suggest, and there's some evidence I found, what looks like actual passage collapses in a couple of these areas. This is the northern cluster. This area has what I think is a passage collapse. As a matter of fact, this long linear thing right here, which connects a couple of sinkholes, is probably a passage collapse. There's another one up here. At any rate, this has, again, when I modeled it, a lot of these things are 20 to 40 feet deep. There's just dozens and dozens of them in a given area. There's 38 here in this particular view. This is kind of where they're modeled again. You'll notice that same trend going through there. And this is a zoom in close. And you can see that they're pretty smooth side. Some of them have rough edges, but most of them are pretty smooth side. And you can see that there's a lot of texture, okay? A lot of pock marks in here. And every one of them, I thought these were all prospect pits when I first went out to look at them. And every one of them was a sinkhole. Every one. I couldn't believe I could find this many in one small area. This is filled in again. So you can see some of these are pretty deep. And these areas right here where these lines are where I think there's collapsed passageways. So there was caves in the area, pretty sure. So, I mean, this is a great tool for identifying karst. So I'll keep going. Here's another area, actually much further to the south. And you notice you still have that same trend. There's a group of sinkholes right here. There's a group of sinkholes in here strung out along a valley bottom. And these actually daylight into an open space that you can see from aerial photography. So I know that there's something underground. And then there's a smattering of what I would call isolated ones as well. This is a close-up of one area, and you can see 3, maybe 4 or 5 dimples in the ground here, 2 of which are pretty ragged edged and fairly significant. This is when you do the fill, and you'll see that there's also broad areas that are below level. This area, this big blue area down in here, is a formation of a large doling in here. So there's a lot of solution going on. And you can see these have very ragged edges up in here. These are collapsed sinkholes. So there's likely that there's a cave in this general area. And this is just, you can see that there's a lot more in there. And there's actually, there's probably more in here than I've given them credit for. If I get in and look at this on the ground, when I start mapping on the ground, I'll look at pretty much every one of these big blue dots and see whether or not there's anything there. This is another area. You can see some texture here. These are very ragged edged as well. These are collapsed sinkholes that are all down along the valley bottom. This is what it looks like when I mapped them in. And a lot of these, you go, oh, I didn't see that. But then you turn it off and you go, oh yeah, there's a little dimple there. And some of these are pretty shallow, but they're indications that solution is ongoing. And then there's a string of them along the valley bottom that are all connected together by negative space. And when it drains internally, means that is a collapse and or an area where there's no outflow of solutions and it's flowing into the ground by and large. And there's dozens of these in this particular area. Now this big blue thing up in here is another type of sink called a stock pond. Okay, so you can identify stock ponds, and I know where every stock pond in the Northern Hills is right now. I've got probably the best database of where every water improvement project ever was. At any rate, this just shows a whole series of these things. So I'll move on. This just, I don't want to bore you guys. Anyway, this area has and it's way off on the northern edge up in here. Up in this area. This is what I call a laflamme. And it's because this big ridge up in here is a major anticline. And it's where the fish hatchery is, and you have all of these major karst springs up there producing huge volumes of water coming out of the ground. And they're coming up out of the ground out of cave systems, big cave systems. Anyway, this particular area, even though the spearfish formation had, I said, 800 and some odd, this is the biggest concentration. And this is just kind of a little zoom in, and you can see how they're clustered. And there's major clusters in here, okay? But even up in here, you still see kind of that same trend, okay? That west-northwest trend. This is an area that has just hundreds of dimples in it. And when you do the modeling, you can see that there's dozens, hundreds of depressions in here. I've only got about, I want to say this particular one has about 125 sinkholes in the cluster. That's just an incredible number. And this is in the spearfish formation, okay? So this is what the spearfish formation is capable of and what it has in a lot of areas surrounding the hills. It is riddled with sinkholes. So if you live on the spearfish formation, and a lot of people do, it's something to be considered, okay? You probably, if you're going to build a home out there, go ahead and build your home, but have somebody qualified take a look at your ground, okay? I know that's probably heresy to say that, but you really should have somebody do a geotechnical study on your ground just to make sure that you're putting the right kind of foundation in and that you don't have evidence of subsidence there, okay? Just a word to the wise, and no, I don't do these surveys. I work for the government, so I can't do that. Pardon? Did you? Yeah, I did. I've been asked that more than once. Now here's some aerials. I'm almost done now, so I'm pretty much at the end. This is an aerial of an area in the spearfish formation, and I found some sinkholes out here, and I said, these look like caves. And Nick and Adam and a couple other folks, and yeah, and he went out to take a look at it, and indeed there were caves out there. Okay. Pardon? And houses are built all over them. That's right. So, you know, you really need to be cognizant of this sort of thing. Now, there turns out that right over in here, there's a sinkhole, and there's probably another one here and there. You can actually tell up in here looking at the aerials. So you can tell quite a bit from aerials. But what you can't tell is how severe they are. And you look at the LiDAR, and you can see holes in the bottom of these sinkholes, which mean they go into underground space. You got a hole within a hole. That's a pretty good estimate. And the owner of this land wouldn't let us go in, but did say they'd take us in there when he's a little bit less under the weather. And he said him or his brother, was it? That his brother had crawled from one sinkhole to the other sinkhole. So there's a cave there. So, I mean, so this technique is finding caves. Okay, I've found at least this, if you count these, we found at least 9 caves using this, and we've only looked in a few areas at this point. Some very limited sort of thing. This is what they look like modeled in, and there's also a big doline up in this area. There's major sinkholes, and these are really deep. These are 30+ feet deep. And they're actually like stream capture. There's a stream running in here, and it disappears into a hole in the ground. And that hole in the ground is basically where it's captured the flow of the stream. And that stream is now underground and dissolving rock, which is just, in my opinion, truly awesome. Okay, and I think that's almost the end. And no, this is one other area. And this area, we found another sinkhole with a hole in the bottom, but people were burning trash. And so there was a big pile of trash in here. And so they said, yeah, when we burn it out, you can come out and look into the hole in the bottom. If you have a sinkhole on your property, please do not burn trash in it, because it's a one-way tunnel into your groundwater.
Call us and we'll map it.
Pardon? Call us, we'll map it, and we'll help you find a different place to put your trash, okay? And I'm almost at the end here. I think that was it. This is this other area, and again, there's big sinkholes here, and there's clusters of these things all over the place, and a lot of them just north of Rapid City. So I think that's pretty much it. So did I keep it under an hour?
So Carl, we're gonna go ahead and open up to numerous questions.
Okay.
Here. Are the questions in the chat, in Zoom, or Facebook? Yeah, so I have some few questions here that we're going to address. So the first one, Kirby Johnson would like to know the approximate thickness of the ceiling of the mine below the housing development, and know the extent of the mining evacuation below the homes and interstates.
Well, the interstate, I don't know what the plans are there. I estimate that below the interstate, the rock's probably 60 feet, the whole 60 feet down. There is about 1 meter, 2 to 3 feet at best of material left in the seal. So there's not a lot of strong material, and that's of the gypsum. Above the gypsum is shale and thin layers of sandstone, which will not hold ground. So if you're directly above one of the openings, you don't have a lot of support.
So I know we were talking about the drones. How close do those drones get to the surface?
Within 1 or 2 feet.
Now, I have been addressing some comments on here about people safety and kind of asking that, but some people are asking if they're safe touring the area, and you can comment on that, your opinion. I know that we aren't.
I would say that it's not too likely that any kind of a sinkhole is going to be catastrophic and happen within 2 minutes. So in other words, if it's going to develop, it's going to be it's going to take a matter of hours, and you'll have enough time to get out. But on the other hand, it's a risk I personally wouldn't take. You never know. You could walk out your back door and there could be a 30-foot hole there. And I've seen, at least in one backyard, there's a 30-foot hole with a car bumper in the bottom. And so, and if you weren't aware or went out there at night, that could be life-threatening. So, so far, we know the impact to the surrounding area is what, 6 homes? Something like that, 6 to 10. 12 homes are directly have been evacuated. For the interim, I'd stay out. I think the emergency management people were talking about getting in and maybe doing some remote sensing with, oh, excuse me, need to quit sharing. And I'm so sorry. Oh my goodness.
Carl, can you, oh, yeah, there's a question about our survey being 0.44 miles.
Yeah.
Can you explain what kind of area that covers and clarify what that means?
Okay, that means there's 0.44 miles of survey traverse. That doesn't mean it's from one end to the other 0.44 miles. It means that we drew a line and measured on both sides of the line over about 0.4, a little, you know, call it 0.45 miles, okay, over a distance. That, it's more indicative of the volume in this particular case than the actual length.
So I guess the best way to ask, how big would you describe the chamber? You know, it's a big room with pillars from end to end. It's where, how big would you say the overall room?
The overall room, some of them are 60 to 70 feet across and well over 100 feet long, but it's just one huge room really with pillars in it. I mean, the entire thing that we looked at, I would consider to be one large underground stope with very few pillars left, to be really honest. So if you're directly over that particular area, you don't have a lot of support underneath. And I personally would not go back into the area until something has been worked out. I mean, there are ways to backfill into there, but they're really expensive. And it depends who's going to foot the bill. I mean, in an active mine, if you have a stope that size, what they do is they take material from other parts of the mine and usually finely ground material and wash it in as sand. So you could sand fill the thing, but that's an expensive proposition when you got to buy sand. I don't know, you know, sand's not a cheap thing. And you might sound cheap, but when you're talking about filling a hole like that, that's a lot. But that's one possibility. Grouting is another one, but that's immensely expensive. But an individual home wouldn't necessarily have to grout the whole thing. I mean, you know, that might be within somebody's reasonable thing to do to save their home. At least with knowing where the mine is and knowing perhaps there's not that much of it under their home, that might be an option for some folks. But in some areas, it's hard to, I personally would be very leery of trying to do that kind of a fix because there's areas and voids that are unknown at this point, a lot of them. And so you could just be, you know, stopping one problem and starting another. So, okay, is that?
I can provide you with a lot of different questions. But lots of people have questions about your thoughts on ground.
That would be an excellent choice at this point. Yeah. Pardon? Repeat that?
Yeah.
Okay. Oh, okay. You mean the question? Okay. The question is, how appropriate would ground penetrating? Okay. You can dress me up, but you can't take me out. Okay. Yeah. I'm sorry, guys. My filters are gone. Okay.
The access point. So they would like to know what about the houses on the other side of the border and the surrounding communities.
To the west.
Northdale specifically. I don't know where Northdale is.
Northdale is that particular, that used to be called Northdale once upon a
By the
time.
water tower.
By the water towers. The mining that we know of is trending in that area. But we did not see any continuation going in that area. However, there are photos from the 1920s, not so much from the 20s, from the 1930s, which showed that there was possibly some collapses during the 30s that are outside of the area that we currently know that the mine, that we mapped mine working. So there's probably more workings in there. There's even to the south end, we showed that the mine ends at the south end and doesn't go anyplace. But I found on an old photo something that's obviously a collapse to the south of there. That's probably been backfilled. It may have only been just a pit in the ground, but it needs to be investigated. Somebody needs to take a look at that area. And ground penetrating radar would be an excellent choice. It won't be perfect, but it will tell you if there's void space out there.
Hey, Carl, a number of people have asked, if you live in this neighborhood and let's say your sidewalk was cracked and your basement was failing, or your yard had a bunch of creases in it, what would you do about that? What would you do? Who would you call? What would be the best? Would you move? Would you?
I would probably move at this point, to be perfectly honest. I'd move until that ground penetrating radar, was in place, until somebody had done some testing in the area to see whether or not your ground was stable.
Carl, there's a question about if you would recommend using ground penetrating in the surrounding area.
Yes,
Okay.
yes, and more,
Like a
yes.
like a buffer.
Yeah, like a buffer, because there's 2 layers of gypsum out there. There's one at the upper, it's what they call the gypsum springs member, if you want to call it that, the zone, which is the area that we know the existing mine is. There's another one lower down, which may have some workings in it. We don't know. I would say that immediately to the west, like the next street over to the west, probably doesn't have too much to worry about, because I think it was on the surface at that place, at that point. So any mining done there was surface mining. So, but as you move farther to the west, that second layer may come into play. And to be really honest, you'd be better safe than sorry. I think it's just a good idea to have testing done. Have somebody, if you can get ground penetrating radar done, something as simple as doing some earth auger work in your area. I mean, that's not all that expensive. And you could ground penetrate. You can do all kinds of soil and rock tests to make sure that you don't have a lot of void space down there. Yeah.
Carl, how applicable would geotechnical work be for this kind of thing? And how close would the holes have to be for it to be meaningful for a house, for
Well, you could put one hole in and it could be representative. You could put one hole in and it could go through a pillar. I mean, that's an impossible question to answer. And I would say that if you're on trend with a known series of workings, you want to go pretty tight. If you're away from workings, a wide spacing is probably appropriate. But that's only a guess. Ground penetrating radar, though, that type of thing does looks at a broader area. So that technique gets a lot more coverage, more bang for the buck. And so if you're going to go one or the other, I'd go for the penetrating radar.
There have been several questions, Carl, about the trend of the mine passage from the sinkhole. So people are asking, are there passages going west? Are there passages going south? Are there passages going towards the interstate? So can you just briefly speak about the trend of what we mapped?
Okay, the trend.
So about 50 people said,
Okay, so because they can't hear the question. Okay, they can hear me, but they can't hear the guys who are giving me prompts. We need to shoot the moderator is what we need to do.
Vocal description.
Vocal description. Okay, so someone asked whether or not, to talk about what the trend of the underground workings are. And it's more or less I'm going to say it has a trend of about 340 degrees, so about 20 degrees west to north, and which means also 20 degrees east to south. And so it's running not parallel to the street, but starting from where the sinkhole is, it's going towards the homes on the east side of the street as you go down. And pretty much from where the sinkhole currently is, where that patch in the ground is about the trend of what the known workings are, because that patch was a hole down into those workings. There are passages going in every direction, but primarily, I wouldn't worry so much about going west, because going west, you're getting very, very close to the surface, extremely close to the surface. And so any subsidence in that area probably took place when they were prepping the ground for homes. I'm still amazed, actually, that nobody knew that was underneath. That's beyond belief to me that somebody wasn't aware that those holes were on the ground there. But I'd say to the west, you're probably a little safer in terms of that particular group of workings. To the east, yes, stuff goes out towards the freeway, and it goes, the deposit gets deeper, but that didn't make it unmineable going towards the east. So going towards the east is the most likely area for more, and towards the south are the two most likely directions for the trend. Because towards the north, it's the zone is kind of weathered away because the topography is dropping, but topography is rising towards the south, and that particular bed is has been followed across the ridge behind there. Back in the prior to there being any homes in the area, it was mapped through the entire area, and particularly off in that general direction. So you had more towards the west, or towards the east, excuse me. Okay, next question. Yes. Okay, I will repeat the question.
Okay. You look, this is
You know, so far, just the hills. But, okay. I'm so sorry. Repeat the question, you bonehead. You know, okay, duh. Okay. At any rate, yeah. Somebody asked whether or not, I just looked for sinkholes in the hills, or sinkholes on the grasslands. So far, I've just looked in the hills. But if you know of any out in the grasslands, we'll look at that area for you. I mean, there's a lot of, LiDAR is available for the prairies in a lot of these areas. We just recently, particularly if you're in either Meade or Butte County, all of Meade and Butte County at this point has been imaged. It hasn't been reduced, but it's easy enough to get a hold of that data. It's all public information. And you do have to have programs to manipulate it, but anybody can go online and download basics. And as long as you got somebody who can manipulate it, and we can, so if you got an idea where a sinkhole is, or think you got one out there, let us know. We'll take a look at it.
Carl, we have a question from Gina Spriegel. She wants to know, are you single?
The question was, am I single? Okay. And no, I am not. I am not. I'm married. I'm very married to a very wonderful woman. And I know she's listening. Okay. Somebody asked if I have dogs for sale. And yes, we do. Labrador retrievers. They're lovely. Yes, they are registered, and we have 5 of them. Yeah, somebody asked what type of dog and whether they were registered or not. Yes, we have registered Labrador. I have the feeling my wife sent in that question. My wife is named Denise. She's, I'm sure she's laughing at me right now. Yeah, the question was, would lowering the water table have an effect on the situation? And I think it's the most likely. That's probably the most likely reason for the collapses happening, is that water levels, dropping water level reduces the amount of structural support. Even though you might not think water would hold much up, air holds up a lot less than water does. And so basically, if you've got water in a confined space, it's to some degree non-compressible. But if you've got air in there, it's 100% compressible. And yes, it would it helps to have that water in there. And lowering the water would desiccate, would allow the area to dry out, and then cracks will develop.
So along with that question, Carl, I think they can hear me if I'm looking directly at the mic because it's directional. If dissolution is happening of the gypsum roof, what rate do you think that would happen at? So if it's 10 feet thick now, how long ago would it have been 11 feet thick? You know, and I think that has to do with infiltration, obviously. So just like a ballpark of how that works, I think is the question.
Okay, somebody's asked whether or not, well, what the rate of dissolution of the gypsum might be over time. I think it's probably relatively slow. You know, it's a fairly massive unit. So, and it's, because it's massive, it doesn't have a lot of, in most areas, it doesn't have a lot of surface area to interact with water. It's a rock that dissolves quite fast, but I don't think that it's, you know, it would take a considerable amount of time for an entire area to decrease by 1 foot in terms of thickness. And I'm talking hundreds of years probably. So it's a fast process geologically, but not fast in terms of our lifespan, I guess. Okay, question was, the older homes in the area, are they more at risk than the newer homes? And I guess I'd say probably not. You know, to be perfectly honest, a lot of older construction is better than modern construction. So, or at least as good as modern construction. And the strength of materials is about the same back then as it is now. So no, I'd say there's probably not a huge difference, unless you've already had a lot of settling in the area, which might indicate that there is something going on or has been something going on. But I don't think they're any more at risk than at least for falling into a hole. If you're above a hole, the amount of damage that's going to happen probably is not going to be directly related to, you know, the age of your house. It's going to be it's just going to be related to the amount of investment you've got in the house. I mean, an old house can cost a lot of money too. So. Okay, no, but I don't think so. I don't think there's any greater risk if it's older.
Should they be working through the county for that?
You know, that's a really good question for the county. And the question is, okay, the question is, thank you very much. I appreciate that. The question was, what are the resources out there for getting ground penetrating radar? And to be perfectly honest, I know that it's available through a lot of consultants, but I don't know from a governmental standpoint of any agencies that routinely do it. But your local government, your local county and city governments should be, at this point, I would think that's probably a good thing for them to be looking into, because it is a situation that, you know, the area is just going to have to deal with.
I think we have to be close to wrapping up the question. But kind of a good question, just stuff we get together. This has asked, do you think the gypsum mine in the affected area where we know it is there a chance for more collapses and sinkholes to form in the immediate future?
The question is, and is there, because we know that the gypsum mine is currently where it is there a potential for more collapses to happen in the area? And yeah, there is. I mean, there's just no way around it. There's very, very likely other unknown areas that have underground workings in them. And we also know, and we currently know, that there is areas we couldn't get access into. So yes, there's definitely potential for more subsidence and collapse in the area. Was any other questions at this point, folks?
Are there any seismic faults anywhere near?
The question is, are there any seismic faults in the area and that would affect these sinkholes? This is not a highly, this area isn't highly seismic, although there has been small earthquakes here. There's no major active faults in the area, but there are hundreds and hundreds of faults everywhere in the area. There isn't a rock out there anywhere, any place that doesn't have at least small faults in it. It's an area that's been undergoing uplift for millions and millions of years. So yes, faults everywhere, but not a lot of active faults. I wouldn't be all concerned about seismic related collapse in this area, at least unless we start having clusters of small earthquakes, to which, to the best of my knowledge, we have not.
This is similar, but the collapse areas that we were not, the places that are collapsed, that you go into were collapsed. Is there a chance of those collapsing again? Which the places that were right touching the ceiling, right? So.
Okay. The question came that, the collapses that we couldn't go into certain areas because there were collapses barring our way. And is there a chance that they could collapse again, or at least lead to more collapse? It's a hard question to answer because we don't really know whether that's a collapse against the edge of the workings, or whether that was the edge of the existing, whether it's in the middle of a group of workings. There's always going to be a chance for more collapse. Yes, I mean, an area that's collapsed once is weakened, and there can easily be collapse in the surrounding area. Anything else, guys?
I think we're gonna go around. I think this already been asked, but someone's again asking the extent of
Okay, question was, how far south did the workings go? We don't really know. Okay, the question is, how far south did the workings go? And we don't really have a good feeling for that because we don't have any old underground maps. We do know that the quarrying that was done on the surface went out several hundred, I'm going to say maybe as much as 500 feet south of where we know the edge of the known workings are. But those could have easily been surface. But there's some indications that, yeah, there was some mining in other areas. We don't know. One of those sump areas could go down and then trend off towards the south, or it could just go down dip. We really don't have a way to tell. But once again, if you can, find some funding somewhere, and don't ask me because I don't have the money, but but to get some ground penetrating radar, that's probably your best bet to tell whether or not where those workings might still be.
Seems like we're kind of out of questions. There was one last question, which was, they just wanted you to restate, what would you do if you were living in the neighborhood? And that's a good wrap up.
Okay, the wrap up question is, what would I do if I was living in the neighborhood? I'd hire a qualified geotechnical person to evaluate the area and have them give me a bid for how much it would cost to do the kinds of testing we've been talking about for the immediate area surrounding my house. Because you could be totally safe or totally at risk, and there's just, you don't want to, I personally would not want to be worrying about that. I would have a qualified person take a look at it, and there's lots and lots of qualified geotechnical firms out there. There's all kinds of them. So that's what I personally do.
It's like, let's push Karl out of the way in his wheelie chair. All right. Yeah, everyone. So I just want to thank everybody for coming out tonight. So once again, we're the Paha, Sapa, and we're a cave and karst science group, and we none of this stuff is we don't charge for anything, and we just do all this just to kind of be like good neighbors to the people of Blackhawk. So obviously everything that we have done, Matt, everything, that's just for your reference and help you guys make decisions, but nothing, you know, we're not a legally binding group or anything. So don't be like, well, they told me to do this, because we're just doing it as friends to you guys, because we want to make friends with you, and we care about you guys. And everyone we met from the neighborhood has been amazing people and great people to talk to and work with. So we feel for you guys, and if there's anything we can do to help you guys at any time, please just let us know, because you know we're local just like you folks are. So once again, thanks for coming out, and I think that concludes our meeting presentation for the night. So thanks again.
Okay, now I will have a beer. Oh, okay.
Carl's having a beer.
Hey, Brett, have one for me, okay?